Yeah, so for students that, need to hop off, that will have a recording. And also if you don't want to be in the recording, either shut your camera off or let me know so I can like make sure you're not in the recording. Um, yeah. Um, so yeah, have started recording. Um, Google Colab is from Google. It's free. There is a paid version, which is why there's this asterisk. Um, but it's really nice because it gives you access to Google's GPUs for free. You just need like a Gmail account. Um, the overall tool has these things called cells, and there are text cells and there are code cells. The code cells actually run your code. So this is a code cell with some code in it, and this is a text cell with some regular text I've put in for directions. Um, the really nice thing about it is it gives you access to GPUs, and also it gives you access to a bunch of dependencies or libraries pre-installed. So like Google knows that, people are probably doing like machine learning things. So it comes pre-installed with like TensorFlow and a bunch of other stuff that now, like if you're using Colab, you don't have to deal with trying to install it on a machine and like running into a bunch of annoying installation errors. So it's really nice that it's all like set up already. Um, Another nice thing about Google Colab is it's all in the browser. So you can just make a notebook and then share the link with somebody. And it's a really easy way to share code. And like if you're like, I'm doing this and it's not working, you can just share the URL with someone else and they can actually run through it. So you don't need to like if you have heard of Git or GitHub, you don't need to like make a repository and then have someone else git pull it and then set up all the dependencies and run it. Like because it's all in the browser, you can just send the link to someone else and they can run it exactly as you ran it without needing to do about a bunch of setup. Those are all the nice things about Colab. Some things that are a little bit annoying is that there are time limits. So with the free version, you have about an 8-hour long session. 8 hours will be enough for like today. The only time you'll run into a problem where 8 hours is not enough is if you're doing training, which we will be doing in like a week or two. Um, you can still work with an 8-hour time limit. You'll just need to log in every 8 hours and like restart the script every 8 hours. With the paid version, you have a 24-hour time limit, so it just bumps it up like threefold. Um, yeah, but I'll get more into that afterwards. And yeah, for now, Yujung, are you ready?
Yeah, so I think I'll share the link to my Colab here in case if anyone wants to follow along. Does that sound okay?
Yeah. Yeah, so Yujung's gonna do a quick demo of Colab and coding. Um, yeah, and I'll make sure you can share.
Enable screen share.
Yeah, there you go. I'll also make you a co-host.
Thank you. Okay. Okay, so I saw in the survey that there were some people who are already like familiar with programming, but I tried to just give a really brief overview of a few concepts in Python. And this is definitely not like a most comprehensive intro, but we also try to cover what Leah's other workshop notebooks contain. So feel free to ask questions as you go. So this is like the interface of Colab. And there are two things. So there's like code cells and there are text cells. So if I click on here, you can see that this is like a separate text cell and this is a code cell. And you can edit these texts by like double clicking on it. And the text is written using Markdown. It's just like a formatting language. So for instance, like if I add two hashtags, it just makes my text bigger. And if I add another one, it becomes smaller. It's pretty simple formatting language. And for code here, the command that I have here is to print the statement. And so in order for you to run any code, you can simply just press this play button. And so if you want to go ahead and try, you can also try, and you will see that it's going to execute, it's going to output this text right below the cell. And these cells, you can't run more than one at a time. And even though you try, so like if you like run all, for example, it's just going to like run in order. Okay, so a lot of these codes, so code cells can contain variables. I'm sure many of you are already familiar with like what a variable is, but for those of us who are not, so if you think about like, you know, if you're playing a video game and we're trying to like keep track of like how much health we have in the game, then maybe we'll use like a variable to keep track of that number. And so in here, I'm going to just, so I'm going to assign the number 12 and title that variable first number. And we'll do the same thing for a different number for the second number. And so if I run that, now my notebook is going to like remember these two variables. So on here, we can try, so this statement just says like, okay, so this sum number plus some number equals, you know, the output, and it's like formatted in a way that this first, you know, argument here will just automatically go here, and the second variable will go here, and the third one will go here. So if I run, it's already ran, so you can see it already. But if you run it, it will show you that, okay, 12 plus, you know, 25 equals 37. We can also change what's saved in a variable. So you see how like here we already saved it as 25, but let's say like I want that to be 55. Then I can rerun this. And now my notebook remembers the variable second number as 55. So what would happen if I run this code again? It's going to tell me 12 plus 55, because we updated, equals 67. But usually it's really not a good practice to have these like use same variable names for two different numbers. So ideally we would just like either delete that as we go, or just change the number on here. Also, even though these three cells are like in a different order, they're like we don't have to run all the cells in like a specific sequence. We can actually see which cell like was like ran before the other cell by looking at the number right here. So this is like the 20th, and then I ran this one, 22, and this is a 23rd. Yeah, so things that I saved here will automatically be applied here as well.
Yeah, so like this is something that is like a common, I don't know, common thing to get used to when using notebooks, is like the order in which you run cells matters. And in general, like notebooks should be laid out so that you just run them from top to bottom. But yeah, just be aware that like even though the notebook itself is laid out and like, I don't know, you might be like, oh yeah, I'm just going to read it from the top to the bottom, and that's the order in which the code runs. Like there might be a point where you need to go back and like edit a variable, and yeah, just keep in mind that the cells themselves have like they have these like the little 20, 23, and 22 tell you the order in which you ran them. So if you want to know like what is the actual latest, most up-to-date value of second number, you should make sure like, okay, I'm gonna like here, it's here, but it's also here. And this one says 22, and 22 is more recent than 20. So that's how you know like this one is like the most up-to-date value. Yeah, does that make sense? Okay, cool. Yeah, carry on.
Thank you. I'll also use annotate. Can you see my mouse?
Mm-hmm.
I can draw, right? Okay.
Yeah, I can see
Okay.
that.
Perfect. All right. So I have a very simple example of like a function. So a function is like a block of code that we can run when we call the name of the function. And you can also use the concept of like looped to repeat like a sequence of instructions. So in here, I have a function that's titled like print number, and I want to print this number 3 times. So I just define a function here like this, and it's going to print it 3 times. I just included it in case like you encounter something like this in the future, and then you can just reference it back to understand, but you don't have to understand it like completely now. One other thing that you will encounter a lot in the notebooks is a file path. And so any files like on your computer or like a server has like an address, and we can access those folders or files using the file path. And so like, for example, like on my laptop, if I have a file that's titled like final paper.pdf and it's in my downloads folder, then the file path might be like home/downloads/final paper.pdf. And so in Google Colab, you can find a file path of like a folder or file by going to here. Like you can see this icon right here. And okay, thank you. And I'll open it. Okay, and you can see that there's a folder named sample data. And if I go like up another, or what do you call it? Like up in the parent folder, then you can see there are many more. So one way to check how to find the address of these, let's see, like go to content and sample data. I can press right click on a file or just pick this 3 dots, and I can just do copy path. And let me just paste it here to see like what that path is. So it tells me that, okay, so within this content folder, there's sample data and readme. And that's just how we will use file path. So you can go ahead and try that for any other files if you wish.
Yeah, and so for a lot of the notebooks, the main thing that you'll be doing most of the time is like substituting in like your image with like the default image. And so you'll be doing like this a lot where you like upload your own image and then you grab the path to it and then like paste it in a cell. Like basically just delete the path to their sample image and then you put in the path to your own image that you actually care about running the code on. And so this will be like a frequent thing that you do.
Oh. Okay, I just tried uploading a file and okay, that's just the address because like it's on the very, very root of my folders. If I moved it here and grab the file path of this image that I just uploaded again, then it's going to show me that now it's within the content folder, sample data folder.
Mm-hmm.
Ta-da.
Yeah, and so you might get like if you get an error that's like file not found, that means you should double check your paths and make sure that they're pointing to the correct file.
Sounds good. Okay, I will move on to commands. So we can use commands to execute like code files or scripts. So you'll see that sometimes, there are files that end in like .py, that those are like programs, like code files or script files that's like written in Python. A script is a text file that contains a series of commands, and we use that because it's very convenient we can conveniently run like one script to execute, say, like a series of different things. If it's like just running one command to run like 10 different things. And within those, and in that command line, we can also give like arguments to it to specify the behavior. It's kind of like changing the settings. And so this is just an example of a snippet that you will encounter in like a notebook that Leah will probably go over later today, right? Yeah. So like running this right now wouldn't work because the file path is wrong. But like, so in here, we're just specifying, okay, the Python is a language that we're going to use. And this IDAO flash digressions.py is a file that we want to execute. And we're using different like options here to specify the, how do I say this? To specify this command, like you can change the radius.
Yeah, they're like variables, like the first number or the second number from before. But when you're running a script or like a command line command, this is the format where there's like a dash dash. Yeah. So this is like saying this variable called pickle, PKL, gets this value of like content/network.pickle. So the variable is pickle, and then it gets this string or this file path as its value. And so you can go in and change these values. You can make this like 0.7, and then the variable PSI will have the value 0.7 instead of 0.6. Just like how before we reassigned the value of second number to 55 instead of 25, I think.
Yeah, this might look like gibberish right now, but it will make much more sense once Leah gets into like Stallion notebook. Yeah. One other thing that it will encounter in a notebook is like git commands. So git is basically like a program that people use to help track changes that were made to files. So if I change something now, but I actually made a mistake and want to go back to the file that I had like yesterday, then I can use like git to go back to that previous version. And so like when we say a repository, it's referring to a Git folder in like our project that help us keep track of changes that's made in that specific project. So you might encounter something that says like git clone. And this just means that, we are cloning this repository in this link to like our Colab project, which you will also encounter in later notebooks.
Mm-hmm. Yeah, so this command you'll often see at the top of a notebook where it's essentially like taking someone else's, like a big folder of code that they wrote or someone else wrote, and putting it in your working space so you can use all of the scripts and code that they wrote. So it's essentially just like pulling a bunch of files and folders from someone else's repository or like their storage place so that you can work with them.
Yes. Yeah, that's what I had prepared. I don't think, do you want me to go over CPUs and GPUs?
No, yeah, I can, we can skip over that.
Okay.
Cool.
Yeah.
Yeah, just about CPUs and GPUs, they're if you go to runtime, one thing is if you go to change runtime type, hardware accelerator, if you're running like machine learning stuff, you want this set to GPU because otherwise you won't have access to GPUs. Yeah.
It'll just be much faster, right?
Yeah. You'll be unable to run any scripts that need to use like the GPU. So like generating anything from a network won't work unless you have that GPU thing set. And then this is just a command that you can use to check, like if any of you are interested in like hardware, like what kind of GPU did I get? This will tell you that you got a Tesla K80. Yeah, sometimes it's a good thing to check, because Colab essentially like they roll a die and they're like, you got to sign this one, and sometimes you get one that's like not so great, and then you'll know later like, oh, my code's running really slow, why is it taking so long? And then if you check this and you get like a worse GPU, then you're like, oh yeah, that's why. Yeah. Cool. Yeah, are there any questions about that, about intro to Colab, and yeah, like how arguments and variables and all this stuff works?
I feel like I'll need to go through it properly, but I just have like a basic like school background in like processing.
Mhm.
But yeah, how different is Python from processing? I guess that's a question.
I think they're like overall pretty similar. Like, or yeah, if you're familiar with JavaScript and like variables and defining functions, it's overall same concepts across many different programming languages. There are just like some little syntax things that'll be slightly different, but I think overall, if you've programmed in processing, you'll be good overall. Yeah. Mm-hmm.
And just quickly, sorry, why are GPUs involved? Like GPUs and CPUs, like why is that a thing?
Yeah, good question. Yeah, basically deep learning and like running machine learning and doing all this deep neural network stuff, all of that requires GPUs, because of like, yeah, GPUs are used for like deep learning, like all this machine learning stuff. They're also used for like any kind of graphics rendering, and like gaming. Essentially, the difference between a GPU and a CPU is a GPU can like do a bunch of very basic arithmetic operations, but a bunch of them in parallel. So you can be like, for every single pixel, like do this operation. Whereas a CPU, like it kind of calculates things serially, so like one by one. And so like if you're trying to use a CPU to like render your screen, it would go like pixel 1. Okay, pixel 1's done. Okay, then pixel 2. Whereas the GPU can do like all of these things in parallel. And yeah, the reason why GPUs are used for deep learning and machine learning stuff is because it can do all of these like basic, multiplications and additions really fast, which comes in handy during the training, where, yeah, essentially during the training process and how the neural network gets good at at like generating things that are similar to the data you gave it, is that it basically like does a bunch of small arithmetic operations to be like, okay, I need to tweak this number a little bit and stuff like that. Yeah. Yeah. And if you're curious about like the tie between these arithmetic operations and how the network trains, I would recommend you watch the 3 Blue 1 Brown series of like, why is it that, calculating a bunch of additions and multiplications can help me generate dog pictures. Yeah. Yeah.
This is kind
Is
of a
that-
technical question, but do kernels have anything to do with it? Do you know what I mean?
Yeah. The word kernel is a very overloaded term, but kernels, there are kernels in GANs or in like these convolutional neural networks. A kernel, yeah, there's like a thing called like convolutional kernel, and it basically this is like getting a little bit into the weeds, but the kernel sort of defines the portion of the image that the neural network is looking at, because it's not looking at the entire image, because you know we don't have enough processing power to get it to just like look at the entire image, and it sort of has this little sliding window called the kernel that's like, I'm gonna look at this part and then this part and then this part and then this part. Yeah, kernels are also a thing. Kernel's a term that's also used for in operating systems. But yeah, that's a term that's used a lot. Cool. Any other questions? Okay.
Oh yeah, the
Yeah.
TP. So I just like quick Googled it, but like TP, I know CPUs and GPUs, but TPU is like an AI assisted situation. Like I guess like what I'm struggling to understand, like, because I know you could choose that as an option, so
Mhm.
why wouldn't you?
I actually haven't used TPUs a lot. Yeah, I think like my knowledge of TPUs is also just Googling, and I think I read that it's Google's hardware for doing deep learning faster on a TPU.
Gotcha.
Yeah, you could
Okay.
try it. I don't know.
Yeah, I'll look more into it. I quick just
Yeah.
Googled for like 20 seconds. So
Yeah. So
All right.
curiosities.
Stop sharing.
Thank you, Jung.
Thank
That's
you.
awesome. Yeah. Yeah, and that Colab notebook Yijang's linked in the chat if you want to like run it on your own time. Yeah. In order to run cells in Colab, there are two ways. You can like use your mouse to hover over the little play button and click it, or if you want to like go fast, you can just press Shift Enter, and that'll just run the cells in order, and sort of queue them up, so that you can like Shift Enter 5 times, and then it'll queue up like cell 1, cell 2, cell 3, cell 4, cell 5, and it'll run them in order. Cool. Okay. Let's go back to our slides. Let me share my screen. And yeah, so that was a quick intro to Google Colab and some basics of code, like pretty much everything you'll need to do the things in this class. I did mention that Colab is free and y'all can like use it right now if you have a Gmail account. There is a paid version, which is $10 a month. You need a US payments account. I think you just need a US zip code in order to use it. And it does give you a longer session time, which pretty much only comes in handy when you're training any model. And you also have a higher chance of getting a good GPU, which is either a P100 or a V100. A V100 is like the best, and a P100 is about like 60% as good or like as fast as a V100, but yeah, all of these numbers and letters don't really mean much. Yeah, and then y'all have used Runway ML last week. The difference, just sort of comparing, contrasting these two tools, is that, you'll know what Runway looks like. And it looks very different from Colab, which is more of a coding environment. Yeah, the nice thing about Colab is that it's free. Like Runway, you get docked 0.5 cent per processing time. or per second in processing time, whereas Colab is completely free. Like you can run it for 8 hours and not be charged a penny. You can use audio input. I do think Runway now supports video input, but yeah, Runway ML does not support any audio input. So if you're interested in using audio input, you'll need to go to Colab. And because it is a coding environment, you often have more control. Like if you want to customize anything, or often if like you find a model on the internet, usually it'll be like a Git repository or a Colab notebook. And so you have a lot more of like the world of machine learning available to you using Colab. Whereas with Runway ML, you're restricted to the set of models that they've decided to upload to their platform and support. Yeah, and the downsides are that because it's this coding environment is there's no graphical user interface, and yeah, you'll definitely run into error messages and need to Google error messages and click Stack Overflow posts. Yeah, cool. I think at this point we can take a 5-minute break, and let's regroup at 33 after. Yeah. And cool. Yeah, so next I'll give you like a quick rundown of like what GANs are with a focus on style GAN. And then yeah, give you some background context on what we're actually doing when we're like generating a latent walk video. And then we're going to generate a latent walk video, so you know what is actually happening when you run the code. So yeah, so GANs are the thing that people use to make images and videos. I've put down here in the bottom, GANs are like specifically for, or in general, they're specifically for visual imagery, like images or video. There are other types of models for text and for music, and I've linked to some of them below. But these are like different names of neural networks, like RNN, which stands for recurrent neural network, is sort of like the same type of term as GAN, which is a generative adversarial network. So yeah, they're just names for different types of neural networks. So again, what GAN stands for is generative adversarial network. It's called generative because it generates images, new images. Like, yeah, and to contrast this, like the alternative is like maybe for Eddie's, like these things, this doesn't generate a new image. It just sort of outputs like a bounding box, like 4 points, and is like, I think this is 78% a person, or I have 78% confidence that this is a person. So that like it doesn't really generate a new image. It just gives you like a decision of like, I'm 0.78 confident that this is a dog. Whereas generative things, like they'll actually like produce new images and produce new content. It's called adversarial, which I'll get into in the next couple of slides, and network because it is a neural network. So the reason why it's called a generative adversarial network is because actually within this one network, like of the GAN, there are two networks. There's like 2 in 1. There's one called the generator and there's one called the discriminator. And yeah, they sort of are pitted against each other when training is happening and they try to like basically like sort of like get over the other person, or they're in this adversarial conflict where one is trying to fool the other one and vice versa. So the two networks are called the generator network, which is the network that produces new images. And then there's also the discriminator network, whose job it is to tell when an image is fake, like generated by the generator, and when an image is real, meaning it came from like the actual photos of dogs that you gave the network to train on. So what this might look like is the generator will generate an image and be like, here's a real image of a dog, and then the discriminator's job is to tell when like it's getting fooled by the generator or not. And through the process of training, like in the beginning, they're both initialized as kind of like very naive, like they're both pretty dumb to start off with. And but then like as training goes on the GPUs, the generator will produce better looking fakes that are more realistic forgeries, and then the discriminator will be, it'll be harder for it to tell. And yeah, the reason why this makes the outputted images of GANs really, really like realistic, and why it was like such a big thing, is because of this adversarial nature. Like this was like a key idea that this smart researcher came up with, where basically it's kind of like, you know, if you've heard of like chess playing AIs, like often they'll train it against each other, like it'll play against itself and then get better in that way. So this is sort of a similar idea where it's like the network is playing against itself to like train itself and get better and better. So yeah, to make an analogy, like you might think of the generator as a forger who's trying to make these counterfeit bills, and the discriminator is like the bank that's trying to tell like this is a real bill or this is a fake bill. So in the beginning, you know, the fakes are really lo-fi and they like, you know, this doesn't look like George Washington. And the discriminator is like, of course this is fake. But then the generator gets that feedback and it's like, okay, I did really badly on this one. I got to do better. Like I got to tweak these, I don't know, like these pixels here and these pixels here. And then it gets to a slightly better forgery. And through this process, it gets feedback from the discriminator of like good forgeries and bad forgeries, like forgeries that like slipped through and forgeries that didn't slip through. And with this, it basically gets smarter and smarter during the process of training, up until a point where it's like really, really hard for like even you and I to tell whether an image is like real or fake. So yeah, all of these images are fake. They're generated by a GAN. They first were thought of or like conceived in 2014 by this researcher named Ian Goodfellow, who, like I said, like the key idea was the adversarial part, like pitting two networks against each other. So they would like basically like train each other to do better. And at first the images were really small and black and white, like 256 by 256. And over time with like advances in like processing power and tricks during the training process, like today most of the images generated are 1024 by 1024 pixels, and they're really like they can fool a lot of people into thinking that they're real people. I'll skip over this so we can get to the workshop part, or like the making stuff part, but I'll drop this in the chat for y'all to play on your own time. Basically, it's like a game where one of these people is real and one of these people is fake. Does anyone want to guess who is real and who's fake? You can just unmute and shout it out.
The one on the left looks more real.
Agreed.
I agree.
Yeah.
Yeah, you're right. Yeah, what was it? What were the clues?
Well, the one on the right looks like it looks more fake. Like it looks more like there's a little bit of like plasticiness in her skin.
Yeah.
Mm. Okay, one more. Who's real?
I'm gonna say real on the left.
Real on the
Very left.
Yeah, y'all are good. Yeah. Yeah, the thing, yeah, there's like weird textures here in the background in his hair. Also, like to me, the giveaway is like the fact that her ring is perfectly a ring and her earring is perfectly an earring. Because yeah, these networks are like they're not really great because at I don't know generating accessories because not every person in the data set had earrings. So it won't generate like very good looking earrings. Okay, cool. And then some quick context. Within GANs and within StyleGAN, there's a thing called a latent space. You can think of it as like this 2D space of points. Essentially, each point will correspond to generating a specific image. The latent space is sort of what the network is learning during the process of training. It's trying to figure out like how should these dots be laid out? Like if I render this dot into an image, like what should that image look like? And the latent space is like basically how the network perceives images and thinks of images. And so different points in the latent space will correspond to different images. And a really nice property of GANs is that points that are close will generate similar images. Like these two images are very similar, but they're slightly different, like with the bangs and this hair right here. And yeah, because of this property, like we can do things like this. And that's how these morphing videos are created, is you have these 2 points and then essentially you're like, for this point, generate a frame, for this point, generate a frame, for this point, generate a frame. And you keep doing that. And that's how you get these smooth morphing animations. It's a result of the latent space having this like nice property that points that are close together are like similar images. And you're essentially just generating it frame by frame and doing a like, like walking from this point to this point.
What is like the data set that's like that this is built on? Just like portraits?
Yeah, it's a data set called FFHQ. It's basically NVIDIA grabbed, I think it was 70,000 PNGs from Flickr. And yeah, and then they trained the network on this.
Okay.
Mm-hmm. Yeah. So here I've illustrated it as like this 2D grid. The way Stallion actually thinks of the latent space is instead of like each point being like defined by 2 coordinates, like the X and the Y, each point is actually defined by 512 coordinates, which is a little hard for our brains to wrap around. But essentially, like instead of this point being like 1 or like being like 5,1, it'll be like 5,1, 3, 5, 4, blah blah blah, all the way up to 512 numbers. So it's just like each point is specified by 512 numbers instead of 2. Yeah, in the process of inference is just when you take a point and then render it as an image. And that's using the network to perform inference. And yeah, this is the thing we're going to do today in Colab. We saw interpolation where you take those 2 points and then you scrub along it to generate everything frame by frame. One thing you can do is you can perform an interpolation video called a noise loop, where you just start at some random point and then according to simplex noise, it just like walks around in a loop and then brings you back. And that'll produce animations that are looping and are kind of smooth. Okay, let's get to making stuff. Actually, let me share my screen again. So I think we can all stay in the main session. You are all going to make a Stallion noise loop, which is what we just saw, that illustration of the wiggly circle in Google Colab, and then share it in the slides. So these are like essentially the step-by-step instructions. The notebook that you'll be using is this one. I'll also drop this in the chat. Where's the chat? Oh. Hold on. I'm trying to find the chat. I can't find the chat, but yeah, it's in the slides on slide 54. One pretty important step is after. Oops. Oh, am I still here? Oh, no.
Yep.
Okay. Yeah. One important you need to
Oh.
Okay, I'm back. I think I'm back. All right. So yeah, the first thing you do after opening the link to the notebook is make a copy for yourself. So you have your own copy. Because you should have your own copy so that everything you run is saved. So to do that, you go to File and then Save a Copy in Drive, and it'll make your own copy of it that can be yours, and you can call it like Eddie Noise Loop or whatever. You overall won't need to edit anything. You can just run the cells as is. So yeah, I'll just demo this pretty quickly, and then y'all can follow along or watch and then do it later. But yeah, like Yujong mentioned, usually in the beginning of these Colab notebooks are these cells that do setup. Like this one's the git clone that's taking this repository from GitHub and then just like putting all the code and like putting it here so we can use it. So I can click this little arrow to run it. Actually, I'm gonna switch my account. Yeah, so I can press Shift Enter to run these. This will be like, this notebook isn't created by Google, but you can run it anyway. And yeah, I can just press Shift Enter to have these cells running. And this one is just saying use TensorFlow version 1 instead of version 2 and installing a library. And then this one is copying a bunch of code from this person's GitHub repository into here. So on the sidebar, if I click this little folder, now I have this Stallion2 ADA folder here, because that's this folder that we just cloned and copied into here. And it has all this code that we can use now. This next cell, this little CD, it stands for change directory. So right now we're in this overall place directory, and now we're gonna go into this folder. So this is just saying we wanna work with all the stuff in here. This next cell is the only cell that you might want to play with. You also don't have to play with it. But this next cell will download a pre-trained model. Like these are all different pre-trained models. And it'll download one of them into your workspace. So each of these corresponds to a different ID that'll point to that file. All of these models are stored on Google Drive, and each of these is just a Google Drive ID. And so if I wanted to grab my leaves model, you could just take this and then put this here, replace the ID variable with like the new ID. And then, yeah, that's pretty much it. And if I run this, they'll start downloading it. And it'll take a little bit because these model files are a little bit big. And then if I refresh my file system, I can see it here, network.pickle. Yeah, and then all this -o does is it just tells it like what you want it to be called. So if I call this like network2.pickle, I'll get a network2.pickle here. It's downloading, but it's there. So yeah, pretty much the only thing you might want to change is like if you want to check out some other pre-trained models, you can substitute in the ID with a different ID. And then this cell does the actual noise loop. And this cell will, once you run it, I just click run, it'll start producing the video. It'll start like literally for every point will be like generate the frame, generate the frame, generate the frame, and then they'll smush them all into a video that will be saved in this out directory called noise1. And yeah, now we have a noise1 folder here. And then once it's done thinking, the MP4 will show up inside of here. Yeah. And all the frames will show up in here. Yeah, one thing to note is that this command will take like 4 to 5 minutes to process because yeah, machine learning is expensive even when you have a nice GPU. So yeah, this will do 240 frames. Yeah, if you do want to do more frames, there's an argument you can change, but yeah, this will show you your status. And then once it gets up to 240, you'll get a nice MP4 here. So this is with my leaves model. So this will output an animation of some leaves based on my pre-trained leaves model.
If you were to run it multiple times, do you have to like rename it or add new folders or something, or?
Yeah, so if you wanted to like, let's say I'm running this leaves one and I wanted to try this abstract art one. If you just put this here as is, it will overwrite network.pickle with this. If you wanted to like not overwrite it, you could give it a different name, abstract art. And then the only thing you would need to change later on is here, this is a path to the network, or like the name of it. So here you just be like, it's not network.pickle, it's network abstract art. Abstract art. Yeah. And if you wanted to save in a different directory, because otherwise I think it will just stick it all in this noise1 directory, you could call it like noise2 or like noise abstract art. And then it'll make a noise abstract art folder here. Yeah. It looks like it's done. Let's see. I'm gonna share my entire screen. Also, y'all can start playing with this and start doing it. Let's see what happened. It's a noise loop of some leaves. Yeah. So for now, y'all can only play with pre-trained models, like, content and data sets that other people have trained. But pretty soon you'll be collecting your own data sets, and yeah, you could make all of these animations with your own content if you train your own model. Yeah. Yeah. And then, same deal as before. If you want to share your work, you can just upload it in these slides. One thing with Google Slides is I think if you need to upload a video, it needs to be stored in your drive already in order for you to import a video. So I made this class drive folder so that you can upload all of your MP4s here and link them in the slides. Yeah. Yeah, we're like almost at time, so if you need to go, you feel free to go. But if you want to hang around and continue crafting with this Colab notebook, yeah, I'll be here and hanging around. Yeah, next class we're gonna do this pretty much the same thing as this, but we're gonna do it with a linear interpolation instead of a noise loop. So instead of a wiggly smooth circle, it'll be this polygon where you define specific keyframes and you're like, do this one, then do this one, then do this one. Yeah, and then to wrap up class, yeah, I think now would be a good point to start thinking about what sort of data set you want to collect. And if you want feedback on it, please post in the Slack and I'll give you feedback. Things that you can do for your data set is if you're thinking about scraping images from the internet, look into some Instagram accounts or Instagram hashtags and bring those to class, or go on Flickr and find a search term I don't know, snowflakes. And there are also Flickr groups, which are I think they're kind of similar to Facebook groups where everybody shares photos around a specific theme. But these are all pretty easy things to scrape images from. And we'll go over that next class. Another approach you can take to making a data set is taking a video and then splitting it into frames. So with each of those frames as an image. So that video could be from YouTube. It could be a video that you shot yourself, or it could be a video that you rendered yourself from an animation. Yeah. And then the third approach is you could just take a bunch of photos of things, or you could scan a bunch of photos or scan a book or something. Yeah, overall, this slide goes into a little more detail. Essentially for Stallion, you'll need 1,000 images. 1,000 images is sort of the bare minimum to which you'll be like, okay, I'm good, and I'll get good results. So 1,000 images, it's a pretty high number of images, which is why taking 1,000 photographs will be labor intensive. So it's a good time to think about, what do I have a lot of? Do I have some buried collection of comic books or something, or go digging into your hard drive cemetery to see what you have a lot of. And all of these images you'll need to crop them later on to 1024 pixels by 1024 pixels. So if you have things that are low res, maybe those won't be the best, or you'll need to upsample them before putting them through it. Yeah, and we'll go over how to split a video into frames, or scrape from Instagram or Flickr next class. Yeah. Any questions so far? Any questions about that?
I was gonna ask, can we use images from Unsplash and Pexels and things like that? So these are all CC 3.0 licensed images. But since you're saying that we're gonna need 1,000 images, creating my own, let's say, data set.
Yep.
What is a faster way to do? Is there a faster way to do this, or do I have to like maybe put in a number? Let's say mountains is my tag on the image platform, and then I download a lot of imagery around that and then crop it in Photoshop. Or is there a way to do this, like automate this whole process? At least the cropping bit.
Yeah, the
do one-
cropping. Yeah, the cropping can be automated by a script, which I'll go over. Yeah, there are some. Like if you think about cropping rectangle images to square, you'll have to either like center crop all of them or top align crop all of them, which depends on like what your source images might be. But there's like a script that I'll show you all that you can just be like center crop all the images in this folder.
Nice.
Mhm.
Yeah, that could help.
Yeah.
Do all of the images need to be fairly like similar? Like in your leaf example for like, I'd assume they were very like clean and like crisp as a source image, but like what happens, I don't know, if it's like a bunch of like screenshots, like you have a folder with like, I don't know, tons of screenshots and like you use that as a data set. Is it just gonna look like super messy and weird, or like, I don't know, what's the guideline?
Yeah. So overall, the way these neural networks see images is they literally just see it as like individual pixels on this fixed square, and they don't really have a conception of I don't know, like composition at all. Or so or like they don't have a concept of like semantic things, like the fact that all of these are galaxies. It just sees like this one is a thing with a bunch of splotches on it, and this is a thing with a centered subject. And so this set of images would not be a good data set because there's a lot of diversity in the overall composition or form of these images. Like this one has these two have a centered subject, and these ones are kind of sort of like all over the place. This would be a good data set where, there's a similar amount of padding around, and then there's a centered like subject. But if you like, as long as it's consistent, a similar like composition, like if you thought about laying all your images like together and then onion skinning them, or like lowering the transparency, that all of them would like kind of, if you like squinted your eyes, look similar in the composition or layout overall. That in general will produce like a good data set. Otherwise, you might end up with something that's a little bit muddy in the outputs. Here's an example of someone or like a friend of mine who I think he uses Adobe Illustrator to generate a bunch of. He uses an Illustrator script to generate like a lot of these colored vector shapes, and then trained a network on that. And I think it's really, really pretty. So if you're like familiar, like with processing, you could like output like 1,000 images from a script and then train a network on that as well. Yeah. Any other questions?
Yeah. How does this relate, like with text, for instance? I guess our StyleGANs, like how does text generation fall into this? Or are we even talking about that at this point? Is this more about like what it's like you said, like it's just like what's capturing as pixels, or does it change as more of like it understands it's looking at text and therefore the output would be like a script or like a string or something?
Yeah, good question. So Stalgan is pretty much only used for generating images. It doesn't
Okay.
really have an understanding of text. There are other
Yeah.
types of models that like will understand text, like GPT-3 and BERT and RNN.
Oh, okay.
Mm-hmm.
Gotcha.
Yeah. Yeah, I saw in the survey that like text generation was moderately popular, so I'll see. Yeah. I've like trained a GPT-2 network before, so I could see that. If you're interested in training a text generator, you should start gathering a bunch of text in a big text file.
Okay.
Yeah. Yeah.
Yeah, I feel like my original or like my initial thoughts are gonna be pretty labor intensive. Although I don't even know if it'd be like I don't really know what would happen.
Mm-hmm. Yeah, like gathering a data set is pretty much the most labor intensive part of this entire process. And
Yeah.
yeah, it's sort of a rabbit hole, and you can always like be like, yeah, there's always more to do. And it's if you're a perfectionist, it's not really for you. Yeah.
Oh, can it be like less than 1,000? Can it be like around, let's say, 500 or 650?
I would say 500 is like the bare minimum. Yeah, I think 1,000 is like you're definitely good. 500 or 650, like you could try it, and you like I think you have a good chance
So,
of it coming out well. But yeah. Mhm.
so the end output quality would be much better if we have something which is like which gives the network more ways and definition to the entire artwork or the video that we are creating using
Mhm.
that, right?
Yeah, exactly. Because otherwise, you might run into a thing called overfitting, where the model, like if you only give it like 100 images, and it has all of this computing power, it will basically like learn to generate those 100 images, and it'll essentially just spit back what you gave it, but maybe like a little more muddy looking. And it's just, then you've just done all this work and trained for like 20 hours just to kind of get back a more muddy version of what you started with. Yeah.
It's not very wise use of resources, I would say.
Yeah. Yeah. Any other questions?
Yeah. I tried running this program that you gave us in Colab, and it only ran for like 2 seconds, and I don't see that it updates the files. I feel like I'm doing something wrong, but I have no idea what.
Okay. Do you want to share your screen?
Sure.
Yeah. And everyone else, if you want to drop off, you can feel free to drop off. It's being recorded.
See all my tabs.
See?
So I hit Shift Enter to run it, right?
Mm-hmm. Yep.
So I'll do that. And then I think it's done.
Yeah, the top cell is done running. And then you can click Shift Enter again to run this one as well.
So I did. Is it?
It didn't run. You could also just click it.
Okay. Okay, I think
Yeah.
that's.
I
I
think
doing Shift Enter would run all of them.
Oh, yeah, you have to keep pressing it. So Shift Enter will run the first one, and then I'll hop you to the next cell. And then clicking Shift Enter will run the next cell, and then hop you to the third cell.
Very good. That answers my question.
Awesome. Yeah. Any other questions?
I'm just curious about videos too as data sets. I think last time we looked at the wave example, and
Yeah.
then I was wondering for yet an example from Kishi Yuma of like the faces and hands.
Yeah.
Is that an example of like videos being used as data sets?
Exactly. Yeah. If you look at the notebook for the noise sleep, some of the if you want to see some more examples of video as a data set, I like labeled some of them with video data set. Like I did one where I did a similar piece to Kishiyuma where I just recorded like my face and hands and then split it into frames. So you could see what that looks like. Essentially like an image data set that you just like scrape from Flickr will have more diversity than frames from like one video. And so the difference in like what's output at the very end from the GAN is like in a video, if it's been trained on a video data set, like like frames from one video, it essentially will output things that look like frames in the video but without any sense of time. So you'll get like these weird, like unnatural speed up, slow down morphings to different parts of the video. Yeah.
Hmm.
Yeah. And yeah, I guess I would encourage all of you to at least run through this notebook and then maybe drop what you made in here. Oh, look, we have a thing from Eddie already. We have these beetles. Beetle boys. Yeah, so this model of someone, they basically like scanned a bunch of scientific illustration beetles books and trained a network on that.
Yeah, it's pretty sweet. Like
Mhm.
idea.
Hey, what determines the length of the video on these? Would it always be like 10, 8, 7 seconds?
So these are, yeah, like it's some, I think it's hard coded at least right now to 240 frames. If you, yeah, I'm pretty sure there's a thing you can edit to change the number of steps. But yeah, that'll be a thing. Slow down. Generate more. Yeah, there's actually an argument called dash frames, dash frames. So you could you
I think
could
you could alter the frame rate. That would
yeah,
also
there's
show that.
also an FPS here. So you could like be like, I want to generate 1,000 frames, and then I want the video to be 60 FPS. And then if I run this, oh, this is just because I changed the name to Pickle. If we see this should count up to 1,000 instead of 240 from before. And then it'll splice the frames together at 60 FPS. Yep. Yeah, it's going from 0 to 1,000 instead of 240. Yep.
Could you
Anything
add me to
else?
the thread? No, that's it.
Oh yeah. Yeah. I'll do that right after this.
I have a question. How
Yeah.
do you make processing generate a lot of images?
I haven't actually used processing that much, but processing has a nice. They have an editor.
I could speak to this, Leah, if you want.
Yeah. Yeah.
Yeah, so if you make a sketch that generates graphics, you can have it export each frame. Yeah, I guess that's the answer. There's a few tutorials out there that are relatively simple to follow. I think they export as SVG primarily, but you can also do PDF.
Yeah, so you could have like a 4, I don't know, like, I guess I don't really, is it like int Is it like this?
Yep, you're good so far.
Okay.
And I
It
equals
says
0.
I less than 300, or like, I guess you want 1,000 in this case. Oops. And then in here, you'll have something that's like draw random circles, and then something that does like save canvas to a JPEG. Yeah. Does that make sense?
Yeah, that makes sense. Thank you.
Mm-hmm. Okay. Any other questions? Sweet. Okay. Well, then class is adjourned for this week. Oh, we have a thing from Sabrina. If you are hungry for more cool things regarding machine learning, you can play Which Face is Real. There's also this album. It's called Chain Tripping by Yacht. It was Grammy nominated, and all of the melodies and lyrics were generated by an AI. And they have a cool talk on like how it's made from the lead singer. And if you're interested in AI music, there's also this page of music machine learning models from Google. Magenta is a project from Google, but it's really fun to play with this demos page and just like, yeah, like the web demos I think are fun to play with, and you can just like make a bunch of AI generated music if you're interested in audio. Yeah. I think I saw them today at Google I/O. Cool. Yeah, I didn't know Google I/O was today. All right. Yeah. Well, then class is adjourned. Think about your data sets. Look for IG accounts or Flickr pages, or bring a video, because next class we'll be making data sets so you can train your own model. Cool. All right.
Thank you so much.
Yeah.
Okay.
See y'all next week. And if you
Okay.
have any questions or ideas you want to bounce off of me or the class, just post them in the Slack over the next 7 days. Yeah. Okay.
Good, thank you. Have a
Thank
good
Thank y'all.
Bye. Have a good
Bye.
weekend.
Take
Bye.
care.